Welcome to Tactic Techniques, Ansible scenario-based and real-time interview questions and answers. Sample for multi-playbook. Here's an example of a multi-playbook setup in Ansible. Create 2 playbooks, each defining a separate set of tasks to be executed. For example, you might have a playbook called playbook1.yml that installs and configures a web server, and a playbook called playbook2.yml that deploys a web application to that server. Create an inventory file that defines the list of servers that will be targeted by the playbooks. For example, you might have a file called inventory.ini that specifies the hostname and IP address of each server. In a new file called main.yml, specify the playbooks to be executed and the order in which they should be executed. For example, name, deploy web server and application, hosts, web servers, become, yes, tasks, include _playbook, playbook1.yml, include _playbook, playbook2.yml. In this example, main.yml specifies that the 2 playbooks, playbook1.yml and playbook2.yml, should be executed on the servers listed in the web servers group in the inventory file. Run the main.yml file using the command Ansible playbook main.yml inventory.ini. This will execute both playbooks in the order specified, deploying the web server and the web application to the specified servers. By using a multi-playbook setup like this, you can organize your playbooks into logical units, making it easier to manage and maintain your Ansible setup over time. Ansible has a large number of built-in modules that cover a wide range of tasks. Here's a list of some of the most commonly used Ansible modules. Command executes a command on a remote server. Copy copies files from the local machine to a remote server. Apt installs, upgrades, and removes packages on Debian-based systems. Yum installs, upgrades, and removes packages on Red Hat-based systems. Service manages services on a remote server. File manages files and directories on a remote server. Package installs and manages packages on various platforms. Git clones or updates a Git repository. User manages users on a remote server. Group manages groups on a remote server. Shell executes a shell command on a remote server. Debug prints debug information during playbook execution. Template renders templates using Jinja 2. Assemble assembles multiple files into a single file. Linear file adds, removes, or changes a line in a file. Replace replaces all instances of a string in a file. Win_shell executes a Windows shell command on a Windows host. Win_copy copies files from the local machine to a Windows host. Win_group manages Windows local groups. Win_user manages Windows local users. The include_playbook module in Ansible allows you to include tasks from another playbook in your current playbook. This can be useful in a number of situations, such as when you want to reuse a set of tasks across multiple playbooks, or when you want to split a large playbook into smaller, more manageable pieces. Ansible and Chef are both configuration management tools used for automating infrastructure management, but they have different approaches to achieving this goal. Here are some of the key differences between Ansible and Chef. Architecture: Ansible is agentless, meaning that it does not require any software to be installed on the managed nodes. Chef, on the other hand, uses an agent-based architecture, where the nodes must have a client agent installed. Configuration language: Ansible uses YAML, yet another markup language, for defining configuration and automation tasks, while Chef uses a domain-specific language called Ruby. Learning curve: Ansible has a relatively simple and intuitive syntax, making it easier to learn for new users. Chef, on the other hand, has a steeper learning curve due to its more complex Ruby-based syntax. Scalability: both tools are designed to manage large-scale infrastructures, but Chef has a better track record when it comes to scalability, especially in large, complex environments. Performance: Ansible typically has faster execution times due to its agentless architecture. Chef, on the other hand, can be slower due to the overhead of the agent and its dependency on the Ruby language. Community: both Ansible and Chef have large and active communities, with a wide range of community-supported modules and plugins available for both tools. Overall, the choice between Ansible and Chef will depend on the specific use case, the size and complexity of the infrastructure, and the user's familiarity with each tool's syntax and architecture. How to set up Ansible master and nodes. To set up an Ansible environment, you will need to have at least one machine to act as a control machine or Ansible master, and one or more remote machines to act as Ansible nodes. Here are the steps to set up Ansible master and nodes. Install Ansible on the control machine. Ansible is typically installed on the control machine, which can be a Linux or Unix-based system. You can install Ansible using the package manager of your distribution, or you can download and install it manually from the Ansible website. Generate SSH keys. Ansible uses SSH to communicate with the remote nodes, so you will need to generate SSH keys on the control machine and copy the public key to each of the remote nodes. You can generate SSH keys using the SSH keygen command. Configure inventory. The Ansible inventory is a list of hosts that Ansible can manage. You can configure the inventory by creating a file called hosts in the /etc/ansible/ directory. The file should contain a list of the remote nodes you want to manage. Test connection. Once you have configured the inventory, you can test the connection between the control machine and the remote nodes using the Ansible command. For example, you can use the Ansible all-mping command to test the connection and ensure that Ansible can communicate with the remote nodes. Write playbooks. Ansible uses playbooks to define and execute tasks on the remote nodes. You can create a new playbook using a text editor and save it with the YAML extension. The playbook should contain a list of tasks to be executed on the remote nodes. Execute playbooks. You can execute a playbook on the remote nodes using the Ansible playbook command. For example, you can use the Ansible playbook myplaybook.yml command to execute the myplaybook.yml playbook on all the nodes defined in the inventory. That's it. With these steps, you should be able to set up an Ansible environment with a master and one or more nodes, and execute playbooks to automate tasks on the remote nodes. Comparison between Ansible and Puppet. Ansible and Puppet are two of the most popular configuration management tools used for automating infrastructure management. While both tools share some similarities, there are also some notable differences. Architecture. Ansible uses an agentless architecture, meaning that it does not require any software to be installed on the managed nodes. In contrast, Puppet uses an agent-based architecture, where the nodes must have a client agent installed. Configuration language. Ansible uses YAML, yet another markup language, for defining configuration and automation tasks, while Puppet uses its own domain-specific language called Puppet DSL. Learning curve. Ansible has a relatively simple and intuitive syntax, making it easier to learn for new users. Puppet, on the other hand, has a steeper learning curve due to its more complex Puppet DSL syntax. Scalability. Both tools are designed to manage large-scale infrastructures, but Puppet has a better track record when it comes to scalability, especially in large, complex environments. Performance. Ansible typically has faster execution times due to its agentless architecture. Puppet, on the other hand, can be slower due to the overhead of the agent and its dependency on the Puppet DSL language. Community. Both Ansible and Puppet have large and active communities, with a wide range of community-supported modules and plugins available for both tools. Overall, the choice between Ansible and Puppet will depend on the specific use case, the size and complexity of the infrastructure, and the user's familiarity with each tool's syntax and architecture. Ansible may be a better fit for users who value simplicity, ease of use, and faster execution times, while Puppet may be a better fit for users who require a more scalable, flexible, and feature-rich solution. Using variables in Ansible Playbook. Variables in Ansible Playbooks are used to make the playbook more dynamic and configurable. Here are the basic steps to use variables in an Ansible Playbook. Define variables. You can define variables in the playbook itself or in a separate variables file. To define a variable in the playbook, use the vars field at the top of the playbook. For example, vars http_port 80 https_port 443. Use variables in tasks. Once you have defined a variable, you can use it in a task by enclosing it in double curly braces. For example, YAML name, configure Apache ports, linian file, path, /etc/httpd/conference/httpd.conference, regex, *listen \s+$80, line, listen, http_port, notify, restart Apache. In this example, we use the http_port variable in the line field to set the port that Apache listens on. Use conditionals with variables. You can also use variables in conditional statements in tasks. For example, YAML, name, start Apache, service, name, httpd, state, started, when, http_port == 80. In this example, we use the when field to conditionally start the Apache service only if the http_port variable is set to 80. Override variables. You can override a variable by passing it as an extra variable at runtime. For example, Ansible playbook myplaybook.yml http_port =80 80. In this example, we pass the http_port variable with a new value of 8080, which overrides the value set in the playbook. Variables in Ansible playbooks provide a flexible and powerful way to customize the behavior of the playbook based on different environments, system configurations, or user preferences. By using variables, you can make your playbook more reusable, maintainable, and adaptable to different scenarios. How to configure multiple environments, for example dev, test, prod, in Ansible. To configure multiple environments in Ansible, you can use the inventory feature. The inventory is a file that contains a list of hosts that Ansible can manage, along with other configuration options like variables and groupings. Here's an example of how to define multiple environments in your inventory file. Dev, webserver1.example.com, webserver2.example.com, prod, webserver3.example.com, webserver4.example.com. In this example, we have defined two environments, dev and prod. The dev environment contains two web servers, while the prod environment contains two different web servers. You can add as many environments as you need to the inventory file, and you can assign each host to one or more environments by listing the host names under the appropriate section. Once you have defined your environments in the inventory file, you can use them in your Ansible playbooks. You can reference all hosts in an environment by using the name of the environment as a host pattern, like this. Name, install web server software, hosts, dev, tasks. Name, install Apache. Yum, name, httpd, state, present. In this example, the hosts field is set to dev, so the playbook will only be run on the hosts listed under the dev section in the inventory file. You can create separate playbooks for each environment, or you can use conditionals in your playbooks to execute different tasks or variables depending on the environment. You can also define variables specific to each environment in the inventory file by using group variables. Group variables are variables that apply to a specific group of hosts, like an environment. To define group variables, create a file in the group_vars directory with the name of the group, like this. #group_vars/dev.yml web_server_port 8080. In this example, we have defined a variable web_server_port with a value of 8080 that applies to all hosts in the dev environment. You can define as many group variables as you need, and you can reference them in your playbooks using the syntax. How do you handle idempotency in Ansible? Idempotency is the property of Ansible that ensures that the playbook will only make changes to the target nodes if necessary. This means that if a playbook is run multiple times, it will always produce the same result. Ansible achieves idempotency by using a check mode that performs a dry run of the playbook and checks for differences between the target nodes and the desired state. If there are no differences, Ansible will not make any changes. Ansible also uses idempotent modules that are designed to be run multiple times without causing any issues. How do you handle errors in Ansible? In Ansible, error handling can be achieved using various methods such as the use of error handling tasks, retries, and blocks. Here are some common approaches to handling errors in Ansible. Error handling tasks. You can use error handling tasks to handle any errors that occur during the execution of a playbook. To do this, you can define a task with the ignore_errors parameter set to true. This will cause the playbook to continue even if the task fails. You can then define another task to handle the error and perform any necessary actions. Error handling tasks. In Ansible, error handling tasks can be used to handle any errors that occur during the execution of a playbook. Here is an example of how to use error handling tasks in Ansible. Let's say you have a task that is responsible for copying a file from the local machine to a remote host. If the file is not present on the local machine, the task will fail. To handle this error, you can define an error handling task as follows. Error handling tasks. In Ansible, error handling tasks can be used to handle any errors that occur during the execution of a playbook. Here is an example of how to use error handling tasks in Ansible. Let's say you have a task that is responsible for copying a file from the local machine to a remote host. If the file is not present on the local machine, the task will fail. To handle this error, you can define an error handling task as follows. Name, copy file to remote host. Copy, src, /path/ to /local /file. Dest, /path/ to /remote /file. Ignore _errors, yes. Name, handle error, debug. Message, the file was not found on the local machine. When, copy.rc equals 0. In this example, the copy task has the ignore _errors parameter set to yes. This will cause the playbook to continue even if the task fails. The RC return code of the copy task is then checked in the error handling task using the when condition. If the RC is not equal to 0, indicating a failure, the error handling task will be executed and a message will be displayed. Note that the ignore _errors parameter should be used with caution as it can potentially hide other errors that may occur during the execution of the playbook. It's generally recommended to use other error handling methods, such as retries or blocks, before resorting to the ignore _errors parameter. Retries: configure a task to retry a certain number of times if it fails. To do this, use the until parameter along with a condition that will be evaluated after each attempt. If the condition is not met, the task will be retried. Blocks: use blocks to group tasks together and handle errors by defining a rescue section that will be executed if any task in the block fails. In the rescue section, define tasks to handle the error. Handlers: use handlers to define tasks that are triggered by other tasks. Define a handler to be executed when a task fails. This can be useful for triggering a notification or performing a specific action. Fail module: use the fail module to intentionally fail a task if a certain condition is met. This can be useful for enforcing specific conditions or stopping the playbook if a critical error occurs. Catching and handling exceptions: use the try and except statements to catch and handle exceptions that occur during the execution of a task. The block and rescue statements can also be used to handle exceptions in a similar way. In general, it's a good practice to include error handling in your playbooks to ensure that they are robust and can handle unexpected issues. In Ansible, the fail module is used to intentionally fail a task if a certain condition is met. This can be useful for enforcing specific conditions or stopping the playbook if a critical error occurs. Here is an example of how to use the fail module in Ansible. Name: check if file exists. Stat: path /path/ to /file. Register: file _exists. Name: fail if file does not exist. Fail. Message: file does not exist. When, not file _exists. Stat.exists. In this example, the stat module is used to check if a file exists. The result of the stat module is registered to the file _exists variable. The fail module is then used to fail the task if the file does not exist. The when condition is used to check if the exists attribute of the stat result is false. If the condition is met, the fail module is executed and the message file does not exist is displayed. Note that the fail module should be used with caution, as it will cause the playbook to stop executing if it is triggered. It's generally recommended to use other error handling methods, such as retries or blocks, before resorting to the fail module. In Ansible, blocks are used to group a set of tasks together. Blocks can be used to logically group tasks and make them easier to manage. In addition, blocks can also be used to handle errors and exceptions that occur during the execution of the tasks. Here is an example of how to use blocks in Ansible. YAML: copy code. Name: copy files to remote hosts. Block. Name: copy file 1. Copy. src /path/ to /local /file 1. Dest /path/ to /remote /file 1. Name: copy file 2. copy, src, /path/ to /local /file2, dest, /path/ to /remote /file2, rescue, name, handle error, debug, message, an error occurred while copying the files. In this example, a block is used to group two tasks that are responsible for copying files to remote hosts. If either of these tasks fails, the rescue section will be executed. In the rescue section, a task is defined to handle the error by displaying a message. Note that the block and rescue sections can also be used with the always section to define tasks that should be executed regardless of whether the tasks in the block section succeed or fail. YAML. Copy code. Name, copy files to remote hosts. Block. Name, copy file 1. Copy. src, /path/ to /local /file 1, dest, /path/ to /remote /file 1. Name, copy file 2. Copy. src, /path/ to /local /file 2, dest, /path/ to /remote /file 2, rescue, name, handle error, debug, message, an error occurred while copying the files, always, name, cleanup, command, rmrf/path/ to /local /file. In this example, the always section is used to define a task to clean up the local files, regardless of whether the tasks in the block section succeed or fail. Blocks are a powerful feature of Ansible that can make it easier to manage complex playbooks and handle errors that may occur during the execution of tasks. Pull-based and push-based are two different methods for managing and configuring systems using automation tools like Ansible. In a push-based system, the control node, or the Ansible server, sends instructions to the managed nodes, or the Ansible clients, to configure or manage them. This is typically done by running Ansible playbooks or ad hoc commands from the control node to the managed nodes. The control node needs to have direct access to the managed nodes and be able to authenticate and authorize the connection. This method is commonly used for on-premises infrastructure or in environments where the managed nodes have static IPs. In a pull-based system, the managed nodes are responsible for periodically checking for configuration updates from a centralized server or repository. The managed nodes download the updates and then apply them. This approach is also called agentless as it does not require a constant connection between the managed nodes and the control node. This method is commonly used in cloud or distributed environments where the managed nodes can have dynamic IPs, or when the network security is strict. Ansible supports both push-based and pull-based models. In the push-based model, Ansible requires SSH or WinRM access to the target systems. In the pull-based model, Ansible provides a feature called pull mode, where the managed nodes periodically check for new configuration updates from a centralized repository or a version control system. In conclusion, both push-based and pull-based methods have their own advantages and disadvantages. The choice between them often depends on the specific requirements of the environment, such as network security, the number of managed nodes, the frequency of configuration updates, and the level of automation needed. In Ansible, a playbook is a set of instructions that define the configuration and management of a system. Playbooks are written in YAML format, which is a human-readable data serialization format. Here is an example of an Ansible playbook with a basic structure. Name, playbook name, hosts, target hosts, become true, tasks, name, task name, module parameter, value, At the beginning of the playbook is the YAML syntax for the document separator, which tells the YAML parser where the document begins. The hyphen is used to start a new list item in YAML. The name parameter is a human-readable name for the playbook, which is displayed in the output of the Ansible playbook command. The hosts parameter specifies the target hosts or groups of hosts that the playbook will be executed against. The become parameter is used to enable privilege escalation, which allows the tasks in the playbook to be executed with elevated permissions. The tasks section is where the individual tasks are defined. Each task has a name parameter and a module that performs the actual work. Modules are the building blocks of Ansible playbooks and can perform a wide range of tasks, such as copying files, managing packages, or executing commands. Here is an example of a task that installs a package using the yum module. Name, install Apache, yum, name, HTTPD, state, present. In this task, the name parameter is set to install Apache, and the yum module is used to install the HTTPD package. Ansible playbooks can also include variables, loops, conditionals, and other control structures to provide more complex automation. The YAML syntax provides a clean and easy-to-read format that makes Ansible playbooks accessible to both developers and system administrators. Thanks for watching, and please subscribe my channel.